Alright, so in this video, we're going to do more questions related to trig identities, but of course, we're not going to do all of them. So I'm going to do alternate ones this time. And in case you have a doubt, please feel free to leave it in the comment sections. So if there's a question that you're facing challenges with, you can find my social media accounts, or you can just leave them in the comment section, just this question from this page, and I'll get back to you. All right, so I'm going to do, for this one, ACEG, and for this one, BDF. All right, I'm going to do the alternate questions. All right, so A, we have 1 over tan x plus cot x. All right, I can write this as 1 over tan x is sin x over cos x, plus cot x is cos x over sin x. All right, this one I can write as 1 over. Now I want to make a common denominator in the denominator. So I need to multiply and divide this term by sin x, right? So I get sin squared x over sin x cos x. And if you divide it out, if you cancel things here, if you cancel this, you get exactly what you started with, right? And for the second term, I need to do the same. Cos squared x over sin x cos x. So basically, what I am doing is that I have cos x here. Another way to think about it is to use the butterfly method. Sin x times sin x gives me sin squared x. Cos x times cos x gives me cos squared x. And I need to multiply my denominator together. So sin x plus cos x. All right. So now I have 1 over sin squared x plus cos squared x. And you can see where I'm going with this. Sin x cos x. So this one, sin squared x plus cos squared x, this simplifies to 1. And sin x over cos x, so that just comes to the numerator, right? So I get this as my final answer. All right, which is exactly what we wanted. And if you're unsure how we got this, you just substitute 1 here, and then 1 divided by 1 over, so 1 divided by a fraction is the same as 1 multiplied by the reciprocal of that fraction, and you get your final answer. All right. So let's do C. You can probably also immediately see how we get this. So one minus cos squared x divided by secant squared x minus 1. All right. 1 minus cos squared x is sin squared x. And if you remember, secant squared x minus 1 is going to give you tan squared x. How so? Let me show you. If you remember the identity 1 plus tan squared x is equal to secant squared x, then if you subtract 1 from both sides, you get this identity. All right. Now, tan squared x, I can write it as sin squared x over cos squared x, which is basically the same thing as multiplying sin squared x by the reciprocal of that fraction, right? And these will cancel out, and you have cos squared x. And cos squared x is just 1 minus sin squared x. And you get your right-hand side. All right. And now, this is very, very simple, this one. Because you have sin x, 1 minus cos squared x is sin squared x. And sin squared x is just sin x times sin x. So you cancel one of them. You have 1 over sin x, which is by definition cosecant x. All right. Now G, it looks a bit complicated, but it's fairly simple. You have 1 over 1 plus cos x plus 1 over 1 minus cos x, right? Now let's use the butterfly method. The butterfly method says I cross multiply here, so I have 1 minus cos x, right? 1 times 1 minus cos x, and I have 1 times, and you keep the sign, right? 1 plus cos x. And then you multiply your two denominator together. 1 plus cos x times 1 minus cos x is 1 minus cos squared x. From a plus b times a minus b is a squared minus b squared. So 1 squared is 1 minus cos squared x. All right. So minus cos x plus cos x will cancel out. 1 plus 1 gives me 2 in the numerator. And my denominator is just sin squared x, which simplifies to not but 2 cosecant squared x. All right. And I think that's what you have here. All right, not but 2 cosecant squared x. Okay, we are done. So b, we have tan x plus 1 over tan x. Tan x is sine x over cos x. 1 over tan x is cot x. Cot x is just cos x over sine x. All right, now we use the butterfly method. You get sine squared x. You multiply these two, you get... So it's just combining. Just write it as one fraction. Plus cos squared x divided by, you multiply the denominators together. Sine x cos x. And then the numerator just simplifies to 1. And you have the right-hand side very simply. All right. Again. Yeah, just write it as one fraction. Let's see what happens. You multiply these two together, you get sine squared x. You multiply these two together, you keep your middle sign, so you have a 1 plus cos x squared divided by, you multiply your two denominators together. So sine x times 1 plus cos x. All right. So if I simplify my numerator, I get sine squared x plus, if you expand the bracket here, you get this expression. All right, sine squared x plus cos squared x, that is going to give me 1. And I'm going to have 1 plus 1, which gives me 2 plus 2 cos x. If you simplify, the numerator becomes this. And I hope you see why you get that. And I have sine x, 1 plus cos x. And if you factor out the 2 here, you have 1 plus cos x in the numerator as well. So these will cancel out, and you get 2 over sine x, which is exactly your right-hand side. All right. And finally, it's basically write this as one fraction. So you multiply these two together, you get 1 plus cos x squared. You keep your middle sign, minus. You multiply these two together, you get 1 minus cos x squared. And then you multiply your denominators together. 1 minus cos x times 1 plus cos x is 1 minus cos squared x. A plus b times a minus b, you get this. All right. Now, if you simplify your numerator, you get 1 plus 2 cos x plus cos squared x minus 1 minus 2 cos x plus cos squared x, right? That's just expanding the two squared terms. And I'll leave the expansion to you. 1 minus cos squared x, the denominator is just sine squared x. All right. 1, you get minus 1 here. Cos squared x, you'll get minus cos squared x. So your numerator is just 4 cos x over sine squared x. All right. Now, let me divide. Divide the numerator by cos x and the denominator by cos x, right? So my numerator becomes 4 because cos x and cos x cancel out. In my denominator, I'll keep 1 sine x and I'll write it as sine x over cos x. And sine x over cos x is just tan x. And that is how you get your right-hand side. So we're done. All right. So we're done with most of the proof questions, and I'll leave these ones for you to practice on your own. All right, so question 12. It says, show that this expression has a constant value for all x and state this value. All right, so we have 1 plus cos x squared plus 1 minus cos x squared plus 2 sine squared x. All right, so this term, when I expand it out, I am going to get 1 plus 2 cos x plus cos squared x plus, if I expand this term out, I'm going to get 1 minus 2 cos x plus cos squared x plus 2 sine squared x. All right, 1 plus 1 is going to give me 2. 2 cos x minus 2 cos x will cancel out. Cos squared x plus cos squared x is just 2 cos squared x. And then I have 2 sine squared x here. Now I can factor out the 2 from this expression, and I'll just have cos squared x plus sine squared x. And this simplifies to 1. 2 times 1 is 2. So you have 2 plus 2, which is going to be 4. So this is just 2 times 1, and you're going to get this expression. So the constant value for all x is going to be 4. So that is the value that they're looking for. All right, so we are done with question 12. Question 13. Express 7 sine squared x plus 4 cos squared x in this form. Basically in terms of sine squared x. And that is fairly simple. All you have to do is write cos squared x as 1 minus sine squared x. And that is it. And now, if you just simplify, you are going to get 3 sine squared x. 7 minus 4 is 3 plus 4. And that is what they want. 4 plus 3 sine squared x. And you're done for A. B says state the range of this function for the domain. So we already expressed this as this, right? For the domain 0 to 2 pi. So now, for 0 to pi, we have sine x here. This was the function that we started with. We simplified it to this. And now, instead of looking at this, we are going to look at the simplified version. 3 sine squared x plus 4. Alright, so for this domain, I know that sine x goes from -1 to +1, right? Sine x, the range of sine x is from -1 to +1, is a continuous function. Alright, so for sine squared x, the maximum possible value is still 1, because 1 squared, the maximum value squared, which is +1 squared, is still 1. But the minimum value is going to be 0. So here, why? Because, well, if you square -1, you also get +1, right? So basically, your graph looks something like this. Once you square it, it becomes something like, sorry, not like this, but something like this. So let me show you on Desmos. Let me try to find Desmos. Oh yeah, here. Desmos. All right. So if you have the graph of sine x, we know that it looks something like this. But if you have the graph of sine squared x, sorry, sine, let me put it in bracket and squared. So if you have the graph of, not there, here, have the graph of sine x squared, it's the green one. See, it looks something like this. So the minimum value is 0 here, and the maximum value is 1. So it goes from 0 to 1, which is what we have written here, right? And it's going to be lower. It's going to be lower. So it goes like this, comes down like this, something like this, if you look at here. All right. So we know that sine squared x goes from the minimum value is 0, the maximum value is 1. And now we just need to match this expression that we have here. So for 3 sine squared x, we just need to multiply this inequality by 3. And because it's positive, we don't need to change the direction. So 3 sine squared x is going to look like this. And for 4, I just need to add 4 on all sides. Sorry, plus 4 is less than or equal to 7, right? I just add 4. And this is the function that we were looking for. So the range is between 4 and 7. All right. Question 14. We have an expression in terms of sine x. So let's just take this expression. 4 sine theta minus cos squared theta in the form this one. All right. Cos squared theta is 1 minus sine squared theta. So I can rewrite this as 4 sine theta minus 1 plus sine squared theta. And I can rewrite this as sine squared theta plus 4 sine theta minus 1. All right. Now, I need to write it in terms something like this, right? All right. So, let's say sine theta is equal to u. So I have u squared plus 4u minus 1. And I am going to complete the square. So if you remember, we have talked about completing the square before, right? So if you try to complete the square, u plus 2 squared, so I have made videos about completing the square before, so I'm going to do it very quickly here. But if you expand this, so what I did was I kept my first variable, and I took half of the second variable. So just the coefficient, I took u, which is my variable, I put it here, and then I look at my middle term. So I need to arrange it in descending powers of u. And then I look at my second term, the coefficient is 4, so I need to take half of that coefficient. So u plus 2, and then I take the whole squared. So if you expand this, I get u squared plus 4u plus 4. But we have minus 1 here. So how do I get from plus 4 to minus 1? Well, I need to subtract 5. All right. And now we just substitute back because u was sine theta. So it's going to be sine theta plus 2 squared minus 5. And that is it. A. Hence, state the maximum and minimum values of this expression for the domain. Okay. So we are not going to use this expression here because it says hence you're expected to use the form that you got in the first question. So we have sine theta plus 2 squared minus 5. All right. Now let's think about this. There are two ways to go on about it. Let me show you the first way. For 0 to 2 pi, we know that minus 1, sine theta is bound between minus 1 and plus 1. All right. So let's add 2. Let's add 2 to both sides. So 1. If I add 2 to this inequality, I get this. Right? So now my curve has shifted up. All right. And now if I square, because all my values are positive, nothing is, because it's bound between 1 and 3, I can easily square it without worrying. So I get this expression. And now, previously, if you remember, my sine function was bound between -1 and 1, and I was directly squaring it. So the minimum value became 0, and the maximum value became 1. But in this case, I have no negative values. So sine theta plus 2 is always positive. So I can just directly square all of the values without worrying. All right, so I get this expression. And 1 sine theta plus 2. So I have minus 5 here. So let me subtract 5. So 1 minus 5 gives me -4. And 9 minus 5 gives me 5. All right. Sorry, 9 minus 5 gives me 4. So 1 minus 5 is -4. 9 minus 5 is +4. So therefore, this is the minimum value. And this is the maximum value. And let me just quickly show you. Here. If you have sine of x plus 2, and you've whole squared it minus 5, then yeah, your minimum value is -4, your maximum value is +4. All right. Now, if you're not sure about when the inequality works or not, you have to worry, because in the previous question, I took sine squared x, right? That was bound between 0 and 1. So why is this different? Why can I square both sides of the inequality in this case? Well, if you're confused about that, here's another approach. All right. I have sine theta plus 2 squared minus 5. That is my function. All right, I'm so sorry. My stylus died, so I'm going to go get the charger. All right. So we have this expression, right? Sine theta plus 2 minus 5. All right. So now, let's think about this. Sine theta has the minimum value of -1. So let me just put -1 here. And if I solve this, I am going to get -4. And the sine theta has a maximum value of +1. So if I put this here, I get +4. So this is going to be the minimum value and this is going to be the maximum value. So that is another way to figure this out. So, but you have to be very careful with this method as well. This at most can be 3, at the least can be -1. So you have to be careful while manipulating this, because sometimes you can have problems with this as well. But either method is fine. And the reason why I could square when it was between 1 and 3 and I could easily square is because all the values are positive. So if I square them, it's not going to be any issue. I don't have to worry about the negative values flipping over to be positive because all the values are already positive. Their squares are going to be positive. All right. So that is question 14. Question 15. I have been given this. I need to show 1 over a is this. All right. So a is 1 minus sine theta over 2 cos theta. 1 over a, if I just take the reciprocal of this, is going to be 2 cos theta over 1 minus sine theta. And usually, when you want to simplify these sort of questions, one way to do so is to multiply by what we call the conjugate. So if I have 1 minus sine theta, I want to multiply by 1 plus sine theta. And why do I want to do this? Well, 1 minus sine theta, 1 plus sine theta. It resembles a format a minus b, a plus b. And that is 1 minus sine squared theta, right? A squared minus b squared. And 1 minus sine squared theta is just cos squared theta. So I have 2 cos theta times 1 plus sine theta. And now cos theta and 1 cos theta will cancel out. So I have 2 1 plus sine theta divided by cos theta. And that is exactly what they have here. All right, so we're done with A. And let me erase this. So I hope you understood the method. All right. So B says, hence find sine theta and cos theta in terms of A. All right. So I know that from this expression, if I multiply 2 on the other side, I get 2A cos theta is equal to 1 minus sine theta. And from this one, I get, if I multiply A here and cos theta here, I get cos theta is equal to 2A 1 plus sine theta. Now, in place of cos theta, let me substitute this expression. All right. So this one gives me 4a squared 1 plus sine theta is equal to 1 minus sine theta. And let me simplify here. I get 4a squared plus 4a squared sine theta 1 minus sine theta. Now let me bring sine theta here and 4a squared to the other side. So this here and this here. So 4a squared sine theta plus sine theta, because I added sine theta on both sides, and I get 1 minus 4a squared, right? I took this expression to the other side. So I can factor out a sine theta, and I get 4a squared plus 1. 1 minus 4a squared. So finally, sine theta is going to be 1 minus 4a squared divided by 1 plus 4a squared. All right. Now, that is the value for sine theta. And now once I know this, let me just substitute this here. Cos theta is just 2a, 1 plus, what is sine theta? Well, sine theta is just 1 minus 4a squared over 1 plus 4a squared, right? Now, I can simplify this as 1, I can write it as 1 plus 4a squared over 1 plus 4a squared plus, and then this one, 1 minus 4a squared over 1 plus 4a squared. And when you simplify everything, you get 2a. If you add the numerator together, plus 4a squared minus 4a squared cancel out. 1 plus 1 is 2, 1 plus 4a squared. And if you simplify everything, you get 4a divided by 1 plus 4a squared. And we're done. So that is everything for trigonometric identities. And in the next few videos, we're going to look at solving trigonometric equations. And that is going to be the end of this chapter.